Hello everybody. Today we're going to do some operations with radical expressions. You can use properties of real numbers like the distributive property and combining like terms to simplify radical expressions. So just like 6x plus 4x would equal 10x, 6 times root 3 plus 4 times root 3 would equal 10 root 3. So that root 3 kind of takes the place of x, and you can still combine them as like terms. So in the blue one here, 7 root 2 minus 8 root 2, well 7 minus 8 is negative 1, so it's just negative 1 root 2, but we don't need to put the 1. Similar to if it was like 7x minus 8x, you would just put negative x. Alright, so 5 root 5 plus 2 root 5 should be 7 root 5, because 5 plus 2 is 7. Okay, so you may need to simplify a radical expression to be able to combine it with another. So from the previous video, we know that this root 28 can become something else. So if we factor this, we get 7 times 4, and 4 is a square number, so we can do 4 root 7 plus 2 root 4 times root 7, and this root 4 can become a 2. So what we really have is 4 root 7 plus, and then here's this 2 times this 2, so we get a 4 root 7. Okay, and then that would equal 8 root 7. Alright, let's take another look. So if we have 5 root 32 minus 4 root 18, currently these cannot be combined because they're not like terms, because they don't have the same radical. But we know that 32 is 16 times 2, and then 16 is a square number. I could break it down into a bunch of 2's and we could pull out the 2 pairs, but I already know that 16 is a square, so that'll work just fine. Then we have 9 times 2, and 9 is a square number as well. So, so it really kind of looks like that, right? And then the root 16 is 4, so that 4 times this 5 is going to be 20, and then we have that root 2 left over. Similarly, over here we have root 9 is going to be 3 times the 4 that was already there is 12, so we have minus 12, and then that root 2 is left over. So now we have the like terms because the radicals are the same now, and we just do 20 minus 12 is 8 root 2. So we can also use the distributive property, FOIL, or the box method to multiply polynomials containing a radical. So here we have root 2 being multiplied to what's in the parentheses here. So we can just multiply to each term in there. So root 2 times root 6 is root 12 plus 5 times root 2. 12 is not simplified, so we know 2 is, but 12 is not, because 12 is 4 times 3, and then 4 is a square number there. So we can actually do 2, because the square root of 4 is 2, root 3 plus 5 root 2. Now we'd be looking for these to be the same so we can combine them, but unfortunately that did not happen, so we are done with this problem. We cannot combine these because root 2 and root 3 are not like terms. Okay, and we can also use the box method, or actually this is a perfect square, so we could make this a perfect square trinomial, but just to show you, using the box method will be just fine. So, or FOIL would be the same thing as the box method. So if we make a box and we have root 11 minus 2 squared, that means again we have root 11 minus 2. So root 11 times root 11 is just 11 minus 2 root 11, and then same thing here, minus 2 root 11, and then negative 2 times negative 2 is positive 4. So because when these radicals multiply together we lose the radical, these now can be combined along with those. So 11 plus 4 we know is 15, and then negative 2 root 11 minus 2 root 11 is minus 4 root 11, because these are like terms. let's see what we got here. So again, similarly, we can use the box method for this, or FOIL, first, outer, inner, last. Box method is kind of, I don't know why I prefer it, but I used FOIL for many years, and then the box method is just nice because it helps with factoring. Let's see, 3 root 6. Okay, so this 4 root 3 times root 6 is going to be 4 times root 18, which we can simplify later. And then 4 root 3 times negative 2 root 3 is going to be 8 times negative 2, so negative 8. And then root 3 times root 3 is actually times 3, so this actually can just be negative 24. We'll go through that again, because the 4 times 2 is 8, and then the root 3 times root 3 is 3, so 8 times 3 is 24, and it's negative. Similarly here we have 3, and then root 6 times root 6 is 6, so 3 times 6 is 18, and then here we have 2 times 3 is 6, but negative, and then root 6 times root 3 is root 18. So a couple directions we can go here. We can simplify these radicals first, or we can combine the like terms and simplify it later, which is the one I'm going to do. So 18 minus 24 is negative 6, and then negative 6 plus 4 is negative 2, and then we have the root 18. So now we can simplify root 18, because that is 9 times 2, and this 9 is a square number. So we have negative 6, and then the root 9 is 3. So 3 times this 2 that was already out here is 6, and then we have root 2. So again, these are not like terms because this one doesn't have a root 2, so we are done with this problem. Okay. Remember difference of squares. It's coming back because it's a helpful property here. So x squared minus y squared equals x minus y times x plus y. Well, the converse of that is also true, where x minus y times x plus y equals x squared minus y squared. So the benefit of that with radicals is if you have this x minus y times x plus y, in this case here, the x is root 8 and the y is root 3, when you multiply this root 8 times another root 8, you get just 8 without the radical. And so here we have 8 because we're squaring it. Squaring a square root is kind of the inverse, so we just get the number that was in there initially. So we have 8 minus 3, and there's no more radicals, which is cool. So that's just 5, right? So we're going to apply that using the next problem here. So we're going to simplify this fraction. Now we know from the previous video that we're not allowed to have radicals in the denominator of a fraction. So how do we get rid of that? Well, using this previous thing, the difference of squares and radicals, we want to get rid of the radicals, right? No more radicals. So if we multiply the top and bottom of this fraction by the difference here, it's called the conjugate. So we have to multiply, whenever you multiply something to a fraction, it's got to be the same on the top and bottom. So notice this 10 plus root 10 plus root 5 times the root 10 minus root 5 is going to be the difference of squares there. So when we multiply root 10 plus root 5 times root 10 minus root 5, we end up with 10 minus 5 on the bottom, which is nice because now we don't have the square root there. And then on the top we have negative 3 root 10. We're just distributing this 3 to both items. Plus, because the negative times negative, plus 3 root 5. And so we end up with negative 3 root 10 plus 3 root 5 all over 5. Now it's okay to have radicals in the numerator, we just can't have them in the denominator. So we are now done with that problem. And finally, we can solve proportions involving radicals. We can use cross products to multiply w times 1 plus root 5, and so we get w plus w root 5 equals 2 times 4, which is 8. And actually, now that I'm thinking about that, we don't need to do that yet. So if we don't distribute, and we just write w times 1 plus root 5 equals 8, then we can divide both sides by 1 plus root 5, and then we end up isolating the w, which is what we want. So we have w equals 8 over 1 plus root 5, but we cannot finish with a radical in the denominator, so we're going to multiply both sides by, or top and bottom, I mean, by 1 minus root 5. So we end up with 8 times 1, so 8 minus 8 root 5 over 1 minus 5. So we end up with 8 minus 8 root 5 over negative 4. And we can simplify that further because negative 4 is a factor of 8 and negative 8, so we can say equals, let's see, I'll just divide 8 by negative 4, so we get negative 2, and then negative 8 divided by negative 4 is positive 2. And so there's our final answer. And that's it. Thanks for watching.